All right, everyone. Hey, as developers, context switching reduces our efficiency significantly, and it can cause us frustration. How many of you would like to work in a world where you get to work in a consistent, expressive, concise, and fun programming language all day, both for app development as well as tools development? I know I'd love that world. When it comes to building for Android, we may use a mix of languages across the entire stack. That's Java, most likely, for Android. It's Groovy in your Gradle, XML for your layouts, and adds context switching that can slow us down and inhibit new developers coming to the codebase or learning Android for the first time. I'm Ty, and I'm an Android developer at Uber, working on our external developer platform. Today I'm going to walk you through this fun new language maybe you've heard about being here, Kotlin, and how it can help make your life a little bit better when it comes to Android development, and a little more consistent throughout the entire stack down into the Gradle plugin and script as well. We'll walk through a short overview of the language, and then we'll dive into some real-world examples with using it with Gradle specifically. But first, why isn't Java good enough? And one of the major talking points these days is Java 8 support, and when we'll get it on Android. Along with the new preview in release and the Jack compiler, we are seeing some glimmers of hope. There's this, we can use part of Java 8, we can use lambdas. If we're on in and above, which is not even released except for the preview, we can use all of the features. Otherwise, we end up in this world where, depending on the version of the Android device, you can use certain features of the language, and that becomes problematic if, say, you want to use streams, but you're targeting a Lollipop device. Keep in mind that if you just wanted to use all of Java 7's language features, not even Java 8, including try with resources, we'd have to target KitKat and up, which is still only about 50% of the market share. Secondly, Java and Android together can be quite error-prone. They have capturing inner classes, for example, that leave your apps prone to memory leaks when it might capture an activity or a context that you weren't expecting it, and using it with an asynchronous operation. There's also other syntactical problems with Java beside lambdas, such as collection streaming and systematic problems that, such as verboseness, nullability, and mutability as well. The syntactical problems can be resolved with a lot of backported libraries. There's some great ones like RxJava. There's backports for the stream library. There's backports for the new time stuff. But the syntactical, or the problems like nullability and the verboseness aren't really solved by using extra libraries. So how about Groovy? I mean, this is a Gradle conference after all. Most of you should be somewhat familiar with Groovy. But I think it has a few limitations that make it not as ideal as well, especially when it comes to Android development and keeping this consistency. First is that it's a dynamic language, which is great. It's very fluid. It's easy to write. But because it's not statically typed, Gradle specifically is going to spend more time processing the language itself. So this is noted to make the Gradle configuration step a little bit slower than it can potentially be with Kotlin. Because it's dynamic, it's a lot harder for IDEs to parse and be friendly to you, to fail fast for you, the developer. It's not going to be able to do autocorrect as well. It's going to take a lot of intelligence on the IDE to really make this a good experience. And Groovy brings a number of performance and memory concerns if we were to take it straight to Android. The standard runtime itself is quite large, and most Android apps have a strong focus on being quite small, especially for emerging markets. I think the Groovy runtime is over 10 megabytes, and that's 2 or 3 times the average app size in Android. So if you were just to add Groovy to Android, it might double or triple your app size. Secondly, because it's a dynamic language, it's dynamically typed, it's going to do funny things to Dalvik. It's going to spend a lot more time dealing with the memory allocation that's happening as that's converted down to JVM6 code, and you're going to have much worse performance on that Android device for the end user, especially in the UI as people are scrolling, doing different things. The garbage collector would just keep hitting. So I believe Kotlin can be pretty effective at delivering on a lot of these downfalls out of the box. I don't think it's quite there yet, and I'll kind of explain these as I go through the talk, but I think we can see a really bright future coming out. So with all its hype, I'm sure you've heard a thing or two by now, especially here, about Kotlin. But for those of you who maybe just showed up today, I'll explain a couple of the advantages that I think it has. So it's built by JetBrains, the guys who make IntelliJ and Android Studio, and it's completely built in the open. So it's easy to understand what's going on. And it's been designed with mobile being one of the first-class citizens that it has in mind, which is really useful for Android developers since there's such a large target audience of the language. And the Kotlin folks reached their 1.0 milestone somewhat recently, so we have more or less a stable API that we can rely on. A lot of developers I talked to when it was in development said, oh, Kotlin looks great, but I'm concerned they're going to be breaking the API, and there's a lot of stuff that I'm not really comfortable that they'll be doing that's not quite there yet. But now that it's a 1.0, I think that we have a little more confidence than we would have before. Since the first time I gave this talk, Gradle has actually announced that they have official support for Kotlin in the build scripts, which is super cool, but it's still in its infancy. And I'll walk through some examples to kind of show what I mean by that, but the dedication by the Gradle team means that we'll probably see this move pretty quickly, and it'll be easier to use before long. Because it's designed with Android as one of the first-class citizens, the bytecode generated by Kotlin is 100% compatible to JVM6. And that means that that case I talked about earlier, if you wanted to use Java 8 features, you'd have to be dependent on the device that you wanted. If you wanted streams, you would have to target N and above. Well, using Kotlin, since it includes the standard runtime and the bytecode is 100% JVM6 compatible, you can use this pretty much on any device that you would expect that's out in the wild. The language itself has a really small runtime, and that needs to be bundled with your application, which, like I talked about with Groovy, would be a problem. But because it's so small, I think the last time I checked, it's around 600K. So that's tiny. To contrast this, if you're from the iOS world or familiar with Swift, the Swift library comes in at about 8 megs. So much smaller, a lot more convenient to bundle with your app. And because it's statically typed, it doesn't have any runtime overhead for Android specifically. It follows Java's mutability model, which is nice, unlike Scala, for example, where it's immutable by default, and it keeps the memory allocation in mind. We don't have the same runtime overhead that we would have by any other dynamic language, like Groovy or Scala, and those can be quite large constraints on Android, like I mentioned. Lastly, Kotlin is a more modern language. It has many awesome features, and it makes development fun again. A lot of people say that Java just feels antiquated, it feels verbose. They'd love to work in something like Ruby or Scala or Swift. And for a lot of those people, Kotlin feels like one of those languages that they can use and have fun with. If you're coming from Scala, it doesn't have quite all of the language features. It's definitely more trimmed down than Scala, but it has a lot of the niceties. But more importantly, Kotlin can help us with the constraints that Java and Android introduced that I talked about a little bit earlier on the Java slide. By utilizing Kotlin's type safety system for nullability, it can help us reduce easy-to-avoid null pointer errors and avoid nasty states that we may get into with memory leaks. Kotlin gives us a great way to reduce the boilerplate code as well. So this makes for much more maintainable code for new developers to the code base. As Jake Wharton, who you may know from many libraries, has described it before, he said, Android APIs are one large inheritance party. And although that works well for them, it puts the burden on the app developer, especially for those seeking an architecture of composition over inheritance. There are many APIs that require they require ceremony for you to complete properly. You have to do things in a certain order. Just think about the steps required for even toasting. You have to create the toast and then call show on it. Or if you want to save into shared preferences, you have to grab the editor, put your content in, and then apply or commit that. That's really easy for a new developer to mess up. Lastly, while Java is really verbose, and it's too verbose in my mind to accurately define a build script, I think Kotlin can do this pretty well. There's some areas where it still needs to be worked on a little bit, working with the Android plugin, but it has enough of this nice DSL and the fluidness that I think it can compete with many aspects of Groovy in your build script. Now, it does provide the much needed type safety, and the autocomplete and the static typing that we talked about would be needed earlier, so that makes the build scripts much nicer. So let's talk about some Kotlin features. Well, we have higher order functions and properties and mixins, and there's quite a lot of these here, and I think I'm only supposed to be talking for 40 or 45 minutes. So I'll just talk about a few that I think relate pretty strongly to mobile development and Gradle development. One of the most common exceptions in Java development in general is the null pointer exception. and it's infamously known as the billion-dollar mistake. Unfortunately, Java doesn't have first-class support of nullability, or something that may or may not be null, like an optional. But by having a runtime check for null, it makes the code much more susceptible, even when null checks are being utilized 100%. Developers may miss that. Having a potential value of null requires defensive programming, which leads to less maintainable code in general. Here's our first example that shows Kotlin's variable assignments. You'll notice that Kotlin uses a syntax where it reverses the type and the name ordering for variable declaration. A little bit different, but not too hard to wrap your head around. In this case, we'll get a compile time exception, because on the second line, we're not allowed to assign null to the variable a. However, in this next example, you'll note the question mark being used along with the declaration. This indicates to Kotlin that the value may or may not be null, and we'll take care of checking that. Once we try to utilize the variable, we'll see a compilation error as well, as we needed to explicitly check for null before we could use it, because of the question mark. You may also note the two different ways of declaring the variable, both var and val. Kotlin uses var to indicate a mutable variable, and it uses val to indicate an immutable value. In the last example on nullability, we can use a few different formats to check for null. In the first line of code, note the question mark in use again. When that is declared, and further method calls on that object will return null if the parent object is null as well, removing the need to do these nested if-null checks all the way down on your method calls. In the second line of code, we'll follow a slightly different format. Instead of utilizing null, we specify a default value using a single expression if-else. In the last example, we take advantage of the Elvis operator to simplify the syntax of the previous example. OK, let's move on to some other cool features of Kotlin, class properties. In this example, we'll define a class called user, and we'll specify a member variable for that name. Using the syntax where we put inline with the class name as one approach, although we could specify it below in the class as well. Although this looks like standard field, this is a synthetic property in Kotlin. This means that the getters and setters are automatically generated, and that is what is being used near the bottom of the slide. We can, however, override the default generated getters and setters to specify custom logic by declaring a get and set method below the property. You'll notice that we changed the syntax for property declaration here as well from the previous slide. This is just another way to declare it. In addition to using properties to clean up boilerplate code, Kotlin offers another concept called a data class. This is designed to be a lightweight POJO and do all of the things those classes normally need. By adding the data keyword in the class declaration, we get this behavior. It'll automatically generate an equals and a hashcode method for you, as well as the toString method with all the constructor parameters that would be needed. And lastly, it'll generate the copy methods with default parameters, so that you don't have to implement builders to copy and paste these immutable POJOs. Data classes have many limits as well, though. For example, they cannot extend another class or be abstract. So I'd recommend looking up the restrictions to see if these are right for you and your architecture. Let's move on to another example. Function literals or lambdas are a great way to make code more readable and have become expected for people dealing with other languages as well. It's a very modern feature. Now, Java 6 doesn't have support for these things, but using a framework like retro lambda that rewrites bytecode from lambdas to single abstract methods is a great way to get this down in Java 6. So you can do this on Android today. Lucky for us, we get it out of the box with Kotlin. In this example, we see a few different syntactical ways to write them. They'll infer the type from the definition, so we can reference the variables directly in the first example. It's a little cleaner. In the second, with only the single parameter, we can refer to it as the standard it notation. Similar to Groovy, we can store the function literals and variables and use them when we need. Expanding on the function literal concept, Kotlin also provides us with higher order functions, or functions that take functions as parameters or return them. This is a very powerful technique to write clean, readable code, and we'll get to see some more powerful examples of real-world use cases using this in Android and Gradle for cleaning these up once we understand the last concept that I want to explain that's kind of required for this. The last concept I mentioned that I want to talk about is extension functions. Kotlin gives you the ability to add methods to existing types. This is very powerful and similar to some other languages like C#. And it's a great way to replace the utility hell that Java has become, where you have a util class representing interactions with an object that's out of your control. The syntax requires that you just define the type.method name, and then the code that interacts with the class as if it was owned by that class. Please note that you can't override existing methods on that class with these. This is only for adding new methods. Another thing to note is that Kotlin only gives you the method in a class when you've defined the function extension in the class you're using it. If you wanted to use it in other classes, you would have to explicitly import, you'd have to statically import that function extension in the class that you wanted to use it. I mentioned earlier that extension functions were a great way to avoid utility hell. But I also mentioned that Kotlin is completely interoperable with Java. So what is this actually doing? Well, it's generating a class with a static method that intercepts calls to the object in Kotlin. But in Java, you can call that generated static util directly. So you can have one code base that has a mix of Java classes and Kotlin classes, and you can interact with those function extensions by calling the generated class directly. Now, if you wanted to use some of these annotations, then you can indicate to the Kotlin compiler how it the name of the files that you want to generate for these function extensions. If you wanted to group methods from multiple classes into one generic class, you could do that with the JVM multi-file class annotation as well. This can be really powerful in Android too. Here's the traditional way of saving an object into shared preferences. You can see that it requires us to init the preference editor, to put the object, and then to call apply. Now this is prone for error because it requires the ceremony of doing every one of these steps, otherwise you don't persist your data. I think new developers especially come into this and they say, well, I put my object, I didn't necessarily realize that I needed to save it, and you're dealing with runtime issues. Why is the state broken? Why don't I have my user's data? So how can we make this better with Kotlin? Well, here's that same functionality, but using the last three concepts we talked about in Kotlin. Extension functions, higher order functions, and function literals. We add a method edit to the shared preference object that takes a function literal that is defined as another extension function of the editor class. Now, that can be a little confusing at first to wrap your head around, but it's incredibly powerful. It allows any function literal passed in to behave as if it was a method on the shared preference editor object directly. This allows us to use the code in a type-safe way, knowing that the string is saved, but without having to worry about referencing the correct editor object, or even if we're using a Lambda to reference it, because we know that we're within scope. As a caveat to note, Kotlin is JVM6 compatible, so using higher order functions imposes certain runtime limitations. Each function is an object, and it captures a closure. So these variables that are accessed in the body of the function, we now have memory allocations, both for the function objects and the classes, and virtual calls that introduce runtime overhead as well. So by adding the inline keyword to the function here, we're telling the Kotlin compiler to compile this code inline, as if we'd written it the very first Java version that I mentioned on this slide. But we get the maintainability and the readability of this example. Now our bytecode between Kotlin and the Java version is identical when using inline. Remember when I said that Kotlin doesn't add runtime overhead? Well, this is one of those features that allows it not to. You do have to be a little more thoughtful in how you're doing this. But if you were using retro Lambda, for example, you might run into the same issue. Every time you are using a Lambda, you're actually using a single access method. And it's creating that, so you get a little bit of memory allocation overhead. These Kotlin features give us a powerful ability to create a DSL. And there was a great talk earlier today talking about how Kotlin is a really good language for DSLs. There's this proof of concept library called Anko that was written by the JetBrains team. And I'm not sure if this will ever really go super far and people using this in production apps, but it really shows off the powerful abilities of the DSL. You can replace XML in Android with a format similar to this. And it uses all these concepts we talked about earlier to create this very easy to read DSL. You may also notice that the syntax is starting to look quite a bit like Groovy, something you may be familiar with from working with Gradle scripts. So maybe by now I've sold you on using Kotlin in your Android app, but we haven't talked about Gradle much. And introducing Kotlin would add further fragmentation to your code base. You may have Kotlin in your Android app, a mix of Groovy and Java in your build system. Maybe your build script is in Groovy, and you have some Gradle plugins that are written in Java or a mix of Java and Groovy. So that's up to 3 languages, or 4 if you're including XML, to think about. Now, that's a lot of overhead, and people in general aren't super great at context switching. And so that's going to reduce developer productivity, having to go between all that and think about their interoperability. So maybe we can take Kotlin to the next level by introducing it to more areas of the stack as well, bringing that into the tools. So I'm going to walk through a small example that is a use case many of us have probably had dealing with Gradle and Android apps specifically. There have been quite a few talks and blog posts and sample projects on how to use Kotlin inside of Android, so I'll be focusing now more on how it interacts with Gradle a little bit. Of course, we first need to install Kotlin to use in our project. Using Gradle, it's pretty simple. We just add a build time dependency and apply the plugin. We can then intermix the .kt files and the .java files in our project, or even Groovy for the Gradle plugins. Be sure to install the IntelliJ and Android Studio Kotlin plugin. It can help facilitate this dependency and provides a Java to Kotlin file converter. It may not create the most idiomatic Kotlin when you do that, but it's a great start. In more exciting news last month, Gradle team announced that they unveiled Kotlin support for the build scripts as well, the Kotlin scripts, KTS. Now, with the benefits of Kotlin in the IDE, with JetBrains working on that, with the autocomplete, with those things that we talked about, I know I'm more excited for the future of what this may allow. But at this point, the integration is really limited. I hacked together this build script yesterday after Milestone 2 was released. Before that, I don't even think it was possible because the Milestone 1 would not resolve external plugins, so we couldn't even resolve the Android plugin. Even with this, you'll notice that I had to put a workaround in here of using a function extension to go at the default config. The reason that we're doing this is when you specify default config in Android, in the Android plugin, it's going at the base implementation, which comes to essentially a flavor. And now, that doesn't provide the min SDK because their assumption is that min SDK should be common among all of your flavors and build types and everything, right? So there is a specific class called default product flavor that when you call the default config, it's using under the hood. But it's only giving you the parent class. So this function extension essentially does the check. And I'm not using default config, which is the Android block that you would be using. I'm using default conf because I said earlier that you can't override an existing function. So this shows that it's a proof of concept. It works. It compiles. I submitted a PR up to the Kotlin Gradle plugin yesterday with an example on this. But I think it's going to be a little bit before the Android team and the Gradle team kind of get this to a place where it's as seamless as writing Groovy builds today. But it's still really cool. Here's a common scenario that a lot of Android engineers would be familiar with. A developer would want to sign an outgoing request with a consumer key and secret for authentication on their backend. In this example, we define the key and secret and then use them with some generic SDK that wants to make these requests. Let's focus on that API key part specifically. One obvious improvement that we can do is to productionize this code is to have 2 different API keys for different build types or flavors. For example, due to analytics, you may want a different key and secret for dev and release. You may want to hit a staging server with one auth token versus a production. Many different reasons. If this wasn't an SDK but your own web service, you'd also want to define the credentials your own way, right? This is super common to maybe any outgoing request. More interestingly, if you wanted to push your code to an open source repo on GitHub, or allow third-party developers to work on your code, maybe contractors, of course you wouldn't want your production key exposed. That's a vulnerability, right? You might not want any key exposed. So ideally, we'd have a way to have a proper separation of concerns. And we'd have these keys provided to the application during build time from a secure location on the CI machine or the building machine. And that would meet the previous concern and give confidence to the developers when he pushes the source code somewhere that he's not accidentally exposing some secrets. This is an example of where Gradle can really shine, is build tooling. What we have here is Android Gradle plugin DSL that allows us to add a constant to the generated build config that's accessible in the Android source code. We're able to define different keys and secrets for various build types and flavors, both of them. Now, the syntax is fairly straightforward, just a type followed by a name and a value to be accessed. But this is still in our repo. It's still exposed, right? So now we have the keys provided to Gradle in a way that's more broadly accessible to our Android source. Although this allows us to provide different keys for different build types, meeting one of the requirements, it still hasn't achieved our other goal of separating those keys out of the repo altogether. So let's look at some other techniques that we can use to finish that out. Gradle provides a number of mechanisms to provide or inject values into the build process. There's the Gradle properties, or also sometimes referred to as there's Gradle properties, also sometimes referred to project properties. And you can use those with -p. They live in various locations, starting in the local project properties, Gradle.properties, but also including the user's home, Gradle.properties, which lives outside the repo. So that's one way. There are also standard system variables set that are running on the terminal. You can use the -d command as well if you're calling this from the command line to provide these. Lastly, you can always load your own custom properties file and then use the values in the rest of your build lifecycle. In practice, these choices vary from team to team, and it's largely driven by your team's policies and structure, what CI system do you use, what your onboarding process looks like for new developers, and other minor constraints. Once we have that property accessible, we can use this getProp function. It uses both Gradle properties and system variables to set the order of precedence and how it resolves them. So this is going to check system properties first, and then it's going to go after project properties. This allows maybe CI to override in a system, and on a local machine, you could just keep that in your Gradle home properties. So you can have your development key for development, but when it comes to the CI build, the system gets set by the build engineer, DevOps. It'll overwrite the key, and you avoid accidental check-ins to protect potentially confidential information of the organization. And here's how we can use that getProp in the build.gradle. Whatever that has been set to, we'll inject that into the BuildConfig class. Now we have the capability to meet both of our requirements. Android is using that, but it's not checked into the source code, and it can change based on your environment. If you have multiple keys, though, it can be tedious to keep track of all the different environment variables required to set up development environment or CI. It can be hard to onboard new people. You might want to create a custom properties file and leave the Gradle.properties checked in for insensitive information like the artifact ID, version number, group name, etc. But you may need that file. If you use a Java-based SDK or library that requires some sort of runtime access of this information as well, or to simply onboard new engineers or a new machine in an easier way. It'd be good if we could generate that file, configure the file to be in the getignore so it's not part of the code base too. So let's create a custom task defined in build.gradle, and we get the values that we need, and then we write them into the build, into a file in the build. If you're a Java engineer that's not super familiar with Groovy, with output stream will be of interest to you. It's just an extension of the file class implemented by Groovy that wraps opening a file, reading an output stream. And conceptually, it's very similar to Kotlin's function extensions as well. Groovy, like Kotlin, does not have checked exceptions, so there's no need for a try-catch here. So now all you need to do is run this task once for whenever you have a new environment, a new developer, or additional keys. And if you add a custom.properties to getignore file, then you can push the code to a public repo without concerns. Your team probably have more than one app, and for consistency, you may want to make sure that every app is set up in the same way, or even better, you want to share and reuse this process for other apps outside of your organization. So we can make that a little more consistent for all your apps by creating a Gradle plugin. Now, a Gradle plugin, as many of you know, has three basic ingredients. The first is the task, and it's typically used to represent an action triggered from the command line or another task. You can also extend the project object for various things. Some examples are providing values from the build.gradle, or a function to the build.gradle, and this is a Lambda object that you normally see for configuration at the top level builds. Lastly, the plugin itself. This is used to bind the previous components into the Gradle lifecycle. And this is generally the business logic that you're seeking. So a very simple way to create a custom task is by extending the default task class. Function annotated with @taskAction will be called when the task is executed. Create file. Function here contains the logic that we wrote to write the values into a custom property file with some generalization here to allow for reusability. This task requires keys an output file to be provided so that each plugin consumer can supply their own list of keys and a path to the file that they want to be writing. Because this code will sit outside of the build.gradle, we could have written it in Java too. So let's go to a simple example to demonstrate why, in this case, I think Groovy makes more sense than Java, and then we can get into Kotlin here in just a bit with this example too. This is what it would look like in Java. Now, as you can see, it's a lot more verbose than the Groovy version. This includes additional null checks and try-catch statements. While Java developers acclimate to the verbosity of Java over time and kind of start to tune it out, when I look at this, I see the functional elements of it. It actively discourages many new developers to this platform specifically, or even to Java. You talk to many Swift or Ruby or Python developers, and the verboseness of Java is a huge turnoff. How many of you have opened up an Objective-C file in the past and had a hard time looking past all the brackets? I mean, that's how people feel when they come to Java for the first time. It's like they get used to it, and then they don't see the brackets, and they can be productive in it, but it's the same problem. And this is just a huge barrier to entry in pretty much the same way. So for dramatic effect here, I'll show you what it looks like if you commented out all the ceremonial code. This is just about as concise as the Groovy version. And as you can see, it's much easier to follow along what it's doing. Now that we've followed this small rabbit hole, let's get back on track with our plugin example. To continue along with the task, another important part is the defined inputs and outputs. Input is the Gradle annotation that marks a field as an input to the task to be completed. And an output file is another Gradle annotation that declares it as an output file of the task and that it specifically is a file that's going to be outputted to. Straightforward. They're particularly important for incrementally building and the Gradle clean task as well. They empower proper caching and fast builds for your plugin consumers. To make it easier for our plugin consumers to configure the task, we will provide an extension. An extension is just a simple class that allows the plugin consumer to provide certain data required to run our plugin from their build.gradle DSL. And here's an example of a Pogo, or a Groovy version of a Pojo, that gives us this functionality. Note that these data members at compile time will be provided with the getter and setter, again similar to the synthetic properties that we saw in Kotlin. To make it a little more idiomatic, we'll also provide the key file to shortcut assignment to file. You can also add the getProp function here in the extension function. You can also add the getProp function here in the extension, so the function can be available to any project that includes the plugin as well, or applies to the plugin. And lastly, the plugin itself that will help us bind and integrate these components into the Gradle lifecycle. First, we want to add our project extension into the project object by using the extensions property. This allows us to access the provided data by the plugin consumer and allows them to use their syntax in the build. The plugin class interacts a lot with the project object. And Gradle provides a configuration function for the project object to allow a more concise syntax for inferring that the project object will be used in the following closure below. You can see on the second line, project extensions for a more concise example that can be inferred simply as extensions with the configure class, which performs like the first example as well, using configure. Another important part of the plugin, though, is to make the task available to the project. The after evaluate closure, if you're not familiar with Gradle that much, means that you want this block of code to be called once all the initialization phase has been completed. Let's say we only add the task if the keys have been assigned. That is, we need to do the after evaluate closure and allow plugin consumers to set it in their build.gradle. Here we can see how you would use the plugin in your build script. So there you have it, our Gradle plugin in Groovy, simplifying your use of web API keys for your requests. Now let's see what that could look like in Kotlin. Here's the syntax that you should be familiar with from the earlier introduction and some of the other talks. We have two fields, keys that are at a list and file that is nullable. We don't need it to be nullable, but for this demo, I'll make it nullable to show how to deal with Java APIs that are nullable by nature in Kotlin. Please pay attention to the first line here. The open here declares that this class is not final. By default, all classes in Kotlin will be final, and so you need to explicitly declare them as non-final. And using Gradle, if we don't mark this as open here, Gradle cannot automatically extend this under the hood, which is what it normally does. Here's a version of the create file function when translated line by line, similar to Groovy. Kotlin does not have a checked exceptions. Any uncaught exceptions will just be elevated to the caller. Here we have another version that's a more idiomatic or concise. We've removed the for loop and replaced it with a for each and a function literal. What's more interesting here is the last line, though. Here we're using the double bang operator. Remember how keyfile was nullable? I mentioned it earlier. What we're saying here with the double bang operator is that if keyfile is null, just throw a null pointer exception up the stack. And that's another way to deal with nullable objects in Java. And in this case, it's going to be elevated up to the caller. Here's our version of the Pojo as a Gradle extension that uses the data class from Kotlin. So it's also quite a bit lighter. We're now looking at the plugin class. Similar to before, we want to add the extension to the project. Again, we want to use the after evaluate here to allow the extension to be set in the build.gradle. Well, this is cleaner than the Java example I showed. At this stage, the code looks still pretty verbose to me. And I'd love to further improve on that. So what can we do? Well, we can utilize a couple extension functions. We can assign a configure function to project in the first line, and an extension on the second line would make this code look a lot more concise and comfortable to those coming out of Groovy as well. So here's the example of how it looks like before and after we use the extension functions to clean this code up. You can see in the second example how we move toward a more declarative and Groovy-like syntax. So now we have the final Kotlin version of our plugin. Just like with Groovy version, we add the extension, and the after evaluation is done. And we create the task to create the file on the extension data. It's declarative, concise, and it's familiar to Groovy developers, but it's consistent with the Kotlin in your Android app, and potentially your build script as well. If you use Anko or a similar pattern in Android as well, I mentioned my concerns about that earlier, but all of a sudden you're pretty much removing everything but Kotlin from your entire build stack. I believe this reduces context switching and overhead, and it allows for a faster move between the different layers of your stack. It makes Android developers more comfortable working in Gradle. It makes your build developers more comfortable working in Android. So nothing to lose there. So we've talked about a lot of info here today, and I kind of went a few different places, and a little bit of an intro to the language, and then the build script, and then some Groovy and Gradle basics, and then finally the Kotlin version of that. So I'm going to list some resources out here, and these are all links, so when I post this later, you can grab these slides and click into these. The first is the official Kotlin docs. They're a great way to learn, they have tons of resources, tons of info. It's a very well-documented language. The Kotlin koans are another great way to learn and play with Kotlin in your browser. It's an interactive web-based IDE written by the JetBrains guys. It has a lot of sample projects and challenges. You can go in there and just pick your challenge and start to play with Kotlin in that way. Anko is that cool plugin that we talked about earlier for writing a layout-based DSL. It's also written by the JetBrains team. This is the official Gradle repo using Kotlin that I mentioned earlier. It's right now just using milestone 2. It has a example just building a standard Java app and one building a Kotlin app. And if I get my PR merged sometime soon, then we'll have just a basic Hello Android in there as well. Not lastly, 2 more to go. This talk by Jake Wharton dives deep into Kotlin to improve Android a little bit more. He uses some of the examples of modifying existing APIs with function extensions to really clean that up and remove a lot of the ceremony. It's a great talk if you're wanting to really dive in on Android. Lastly, my colleague Johan, he put together a sample app from this project that we went through on all the slides, and it's on GitHub, so you can go in there and you can see the Groovy version and the Kotlin version, and it all compiles and you can play with it, and just does injection with generic API keys. The more people use and contribute to Kotlin, the faster we can all have a modern language that we like in our day jobs everywhere. And since Google may take a while to officially sanction Kotlin for Android, if they ever do, I think it's up to us in the community to drive best practices and push this forward. While Google owns Android, since it's an open source ecosystem, we're all responsible for making it better. I can take any questions now, and thanks for your time today. right, anyone want to get started? No questions. OK.
I've got a really basic Kotlin question.
Go for it.
If you have a data class, can you override equals and hash code?
Yes.
Very good.
All right. Yes.
That's easy. What do I need to set up my environment to get Kotlin to produce a simple APK?
Now, when you say Kotlin, do you mean Kotlin in Android, Kotlin in your Gradle, or Kotlin in your plugins?
The whole thing.
OK. Let's say that you wanted to just put it in your Android app and nowhere else. You just need to have the standard library included as an Android dependency, and you need to have a build script dependency so that you can apply the Kotlin plugin as well. Once you've done that, I also recommend you install the IntelliJ IDE plugin to give autocomplete and deal with the language, unless you're just working in Vim or something. But likely you'll want to install that as well. And then you can start intermixing KT files and Java files right away and calling back and forth between the two. And it's very simple. If you wanted to also put it in your build script, it's a little more complicated. You would need to install a development version. When I played with this, I used Preview 3, not Preview 4 of Android Studio, which is based on a recent enough version of IntelliJ that it supported the Kotlin in the build script. I still ran into a lot of issues with it syncing regularly. It would get broken and get in a stuck state, and I would have to exit and reopen it. But did get it there with autocomplete. So once you do that, and you have to reference a specific development version of Kotlin as well, and that is listed in the Gradle Kotlin sample app that is up on the Gradle GitHub repo. So you can see the specific version that they're using, and they have more instructions in the sample README on getting that up and running. Once I get the Android stuff up there too, it might be a better example for playing with Android. One of the major headaches that I ran into in building it there was when using the Gradle DSL in Groovy, it's very straightforward. You just define the Android block, and you just define the default config and the release and the different things like that. And all of those are dynamically resolved in Groovy under the hood. And so since Kotlin is statically compiled, you can't just type an Android block and be good to go. You have to find the explicit Android plugin that you want to apply by class name if you want it to be statically typed. And that required digging into the Android sources a little bit. So here I can pull that back up here, and I'll talk through that just a bit. All right, so you have to apply. This is the class for the Android plugin. And then when you configure, you have to use the extension that the plugin internally is saying, hey, I want to bind this up to the project lifecycle. So I had to dig around and find both of these classes. Now, something like the default config here was also a big pain point, specifically because just the way the inheritance is done under the hood in the Android tool right now. So I'm sure this will get much, much, much better as time goes on. But for the time being, it did require a little bit of digging into the source code to figure out exactly what classes I should be using. Even like using default API version here right now, this isn't an integer. It's using an API level class that I had to find the default API version, which isn't an internal class if I recall, but it feels like it shouldn't be directly referenced in my build script. And then if you want to use it in your plugins, you can just, when you're building your plugin, apply the Gradle plugin and the runtime dependency, and you can start referencing Kotlin right away there too. Yeah?
Roughly how many Java developers are at Uber, and of those Java developers, how many have switched over to Kotlin?
So at Uber, we do not have any Kotlin in production. There are quite a few Android and Java developers that are very interested in Kotlin, that have been exploring it in different regards. Before I was at Uber, I was at Twitter, and I kind of ran into a similar thing. There's a ton of engineers that have it on their roadmap. Maybe they've written some unit tests in it, but it's not in production yet. I do know that at Square, they have a lot of Kotlin in Caviar, and they're starting to put Kotlin into the Register app as well. There's starting to be quite a few apps that are putting Kotlin in production. Right now, the compile still's much slower, and while the IDE integration is very good. It's still not as mature as all the Android tools that have been provided for dealing with stuff. So I see a lot of people watching it, a lot of people starting to play with it in sample apps, put it in unit tests, maybe putting it in some apps. But I think as this year and next year go on, we'll start to see a much heavier adoption of it in the mainstream. Yeah?
Does Kotlin support anything like annotation processing?
What's that?
Does Kotlin have annotation processors?
Yeah, it does have an annotation processor, and it has KAPT, which is similar to APT for Android, so you include that as a plugin, and then you can deal with some of your default stuff. I don't recall if it's the same API. I know that it is. Okay, perfect. For a while, they didn't have annotations, and that was pre 1.0, but I think that came in like 0.9 something or 0.8
They
something.
only run from Gradle scripts though, so beware.
Cool.
Yeah.
There we go.
This is like the cheapers.
Sure.
we rewriting this API. So just right now we are rewriting the KBT so that it's not like patched into the middle of our Gradle plugin.
Yeah.
There's several standalone things that we run from even promote. So
Nice. Cool. I think I'm about out of time. Are there any other questions, or do people just want to kind of find me afterwards if you want to keep talking about Kotlin? All right. Thanks, everyone.